Okay, for this example, the given function s equals some expression with regard to x is a relation between the heights of the ball and for the given time. So in this graph, the y-axis is for the heights and the x-axis is time t. And when you look at this graph very closely, then it looks like we shoot the ball with a velocity of 60 feet per second at the heights of 5 feet. So this graph doesn't start from the origin, but it's actually start from 5. That's the height, right? Original. So when time t equals 0, the height was 5. That's the initial height. And according to the time being, like 1 second, 2 seconds, 3 seconds, the graph shows where it goes, right? So the first 1 second, it goes up to that much, right? And about 2 seconds, I believe, not exactly 2 seconds, but a little less than 2 seconds, it's the highest height, right? It's about 80 or something like that, right? So just before 4 seconds, the heights of the ball, it becomes 0, which means what? It hit the ground again, right? So that's the situation. So when you look at the graph, it's very kind of easy way to understand what's going on, right? So the first question is use this figure, estimate the time. So the answer should be what? T equals something, right? They're expecting some value for t. And that it takes a ball to return to the court, right? To the ground, where it hits the upward and going down ground. And that's just the information which should be already in the graph, right? So roughly, we're just looking for what this value is, right? So it says just estimate, right? So the answer for the first question, t should be 3 point something. You just write down whatever you believe, right? For the right number for that. Intersection points between the graph and the x-axis. Actually, in this case, it's t-axis, right? So that's the answer. And number B, find time for part B by using quadratic formula. Okay, then the typical, the heights with respect to the given time function is given that way, right? So the negative 16 is given because of the gravity in Earth, right? And everything depends on what is the initial velocity and initial position. And that is given over here. Okay, so initial velocity, when you hit the ball, it's a 60 per second, everything in that way. So all you need is just put the 60 for V0 and 5 for S0. So we have a formula, I mean the function, right? The heights with respect to time t is negative 16 t squared plus 60t plus 5. And we are looking for the time at which the ball hit the ground, right? In A, we just give approximation from the graph, right? Just roughly, but we want to really calculate it. Okay? So what is the meaning of hitting the ground? The height must be 0, right? So we are looking for that this becomes 0 at what t, right? We're expecting 3 point something second, right? But we want to calculate it. So look at the condition. S of t equals 0. So we are looking for equals 0. So from a function, we change it to an equation, right? To solve it. And so I just explained that one before, right? The equation in math means the graphical meanings of is we are looking for the intersection between these two functions, right? So left hand side is a function for height, and right hand side is simply just equals 0, right? Height equals 0, so it's x-axis, right? So we expecting two intersection points or two values, and one of them without any calculation it should be negative, right? From the graph, and that is not what we are looking for. So we just accept positive value after you calculate. So all the remaining question is how to calculate to solve this equation. And my suggestion is move everything to the right hand side, because yeah, we don't like negative signs in front of t squared. And we have quadratic equations. We have several different ways to solve it to find t. Now it's your turn.